Hi, everyone. I am Yiran Zhang from Shanghai AI Lab. I am here to present a new RNN architecture for sequence modeling called hierarchically gated RNN. It has been a long history of using RNNs to do sequence modeling. Due to the inherent drawbacks of RNNs, such as lack of parallelism and limited capability in modeling long-term dependencies, it has been gradually replaced by transformers in the deep learning era. However, compared with transformers, the RNNs have their own advantages. For example, they have constant inference speed with computational complexity of ODH, where D is the feature dimension and H is the hidden dimension. They also have linear training computational complexity with respect to sequence length, and they can handle variable length sequences, which means that they naturally have length extrapolation capability. To make RNNs strike back in deep learning era, we need to tackle the aforementioned drawbacks of RNNs. For the lack of parallelism, we propose to use element-wise linear recurrence to facilitate parallelized training. For the long-term dependencies, we propose our hierarchically gated recurrent unit HGRU to model short-term and long-term dependencies. Below, we show the overall architecture of our proposed network. Here we show how to assemble our HGRU from a simple gated linear recurrent layer. Note that the forget gates and the input gates depend only on xt rather than ht-1, to make sure the RNN layers can be trained in parallel. We make following enhancements. First, we use complex-valued recurrence to improve the model's expressiveness. Second, we set a monotonically increasing lower bound on the forget gate values to ensure the network to handle both short-term and long-term dependencies. Third, we tying the input and gorget gates to reduce the number of parameters. And finally, we add output gates to the recurrence layer to stable training. Our HGRU can be also seen in a token mixing perspective as illustrated in this slides. We perform extensive experiments to validate the efficacy of our model. In language modeling, our RNN model performs better than previous RNN-based models such as RWKV with a clear margin. We also scale our model to 1 billion parameters and find it achieves lower PPL on the pile corpus. In downstream tasks, such as common sense reasoning and superglue benchmark, our model performs better than other methods with similar sizes. For image modeling, our model archives better image classification accuracy than transformer-based methods and TNN on ImageNet 1K benchmark. Here we show that our model have sequence length extrapolation capability, similar to Alibi and TNN. Thanks. Please scan the QR code for our network implementation.